All right, guys, we're just about to start another talk. So if you can please get seated. Okay. Hey, everybody. My name is Youssef. I'm a mobile developer at Shopify. And I've been, sorry, let me just make this closer. I've been writing Android apps. Sorry, one second. There we go. Test. All right. So I've been writing Android apps for about 6 years now. I originally come from a Java background. And when I first started out, I had all these different ideas for apps that I wanted to build that I can actually use in my own real life. These are some of the ideas that I came up with when I first started. So I'm a big fan of Internet of Things. I started out by trying to build this smart home controller app. I have a lot of sensors and controllers lying around in my house. I want to put them together and just create a centralized way of controlling my home from my phone. So this was one of the first ideas that I got. I also had an idea for a walkie-talkie concept, an app that I can use to chat with my friends in a quick and instant and fun way. I have friends in different countries, and I just wasn't satisfied with any of the chat apps that I was using at the time. So I figured it'd be a cool idea to build one of those as well. And I had a number of other ideas. I just wanted to build as many apps as possible, and I figured, since essentially it doesn't cost that much doesn't cost anything to put an app on the store, the best way to do it would be to just build those apps, get some feedback from the store, and just kind of iteratively work my way through my prototypes. The first thing that I noticed is that a lot of these apps, or I should say any modern day app, will probably have some or all of these components. I'm going to go through them really quickly. So the first one is a unified login experience. So generally speaking, users expect to have a way to log into the app using a familiar social media provider like Facebook or Google or Twitter. Once they're logged in, there should be a database that can handle the storing of the user metadata, things like the user profile and personalized content for each user. All these apps have the ability give users the ability to publish content, whether it's private content or public content. And all these apps have some way where users interact with each other. So maybe they can send each other messages, but they can also interact with each other's content. So they can comment and they can react to other people's posts. And of course, we live in a mobile-first age, so push notifications is a major part of any modern-day app. So I figured these are the most common components that exist throughout all the ideas that I have. I should probably focus on building these components and then just reuse them in my prototypes. And once again, because it costs nothing to deploy my apps to the store, I figured it's a pretty good idea. It's a pretty fast way to prototype my apps, just by reusing all these modular components. Unfortunately, I was met with a lot of boilerplate code. So going between storage, database, sync, and caching, which I had to do both on the mobile front, and then I had to mirror all that work on the cloud side of things. And to make things even more complicated, I had to repeat this whole work for Android and for iOS as well. So pretty quickly, between cloud APIs, storage, SQLite, push notifications, and login, I realized this wasn't as efficient of an idea as I thought, and I had to kind of take a step back, especially since a lot of these libraries were being constantly updated. And if I wanted to reliably depend on these components that I'm building, I have to update those components as well. But the boilerplate code was just simply unrealistically too much. So I paused the efforts developing those components sometime around 2014. Over the years, more tools were made available by Google that tackle this problem head on. So they take care of a lot of the boilerplate code involved in building a modern day application. I'm sure everybody here, or almost everybody here, is familiar with Firebase. Can I just get a quick show of hands? Anybody who's not familiar with Firebase? Very few people. That's what I thought. Right, so Firebase was actually launched in 2012. I started using it a lot more in my personal projects around 2015. That's when I really realized the full potential of the components that I wanted to build, and they're available out of the box. So for the very few people who don't know Firebase, it's a real-time database that gives you out of the box the ability to log in using your favorite social network provider. It gives you storage options. So if you want to upload any kind of media for your app, it's possible, just outside of the box. Also gives you push notifications through Firebase Cloud Messaging, FCM. So that takes care of another component that we need. And then Flutter was released in May of 2017, so a few years ago. I started using it a lot more in my projects as a prototyping tool about last year. And I found that a combination of these two tools can provide a very powerful combo that you can use to quickly iterate through your ideas. So to demonstrate this, today I want to show you how simple it is and how with very few lines of code we can put together a fairly sophisticated social network from scratch using both Firebase and Flutter. I gave it the name Flutter Connect. And these are, once again, these are the reusable components that we talked about earlier, but with some use cases now. So once again, once we get on Flutter Connect, we should be able to log in using our favorite social media provider. Once we're logged in, we have access to our user profile with all our data. Once we're logged in also, we have the ability to publish to a blog or like a forum, so the ability to publish content that's shared with other users. But also we have the ability to message other users. So a messenger, I would say, is a crucial component of any modern day app. If you want it to be successful, users generally expect to be able to interact with each other. And the way we're doing it in Flutter Connect is to just allow them to chat with each other. And also, when they get notified of any critical events, so whenever a new message arrives, let's say the user is not, they don't have their attention directly on the app. Maybe it's in the background, or maybe the phone is in their pockets. So they want to be able to get notifications for crucial events, such as a new message or new content that they're subscribed to. So let's get right into it. As Boris mentioned earlier, the pub/spec YAML is kind of like the build manifest of Flutter projects. This is where we specify all the dependencies, all the tools, if you will, that we're going to be using in our project. And I opted for tools that were only first party. So these are all dependencies that are maintained and developed either by the Firebase team or the Flutter team. So you know it's going to be constantly kept up to date and you can use it right away. I went for about 9 dependencies, and as you can see, they help me do things like sign in. Let's see if I have a laser pointer. Yeah. So they allow me to do things like sign in. One of them is a UI shortcut library that allows me to map values from Firebase database directly to components on my screen, so I don't have to build a recycler view for the Android developers in the house. And it just takes care of all that. There's also a few other dependencies that allow me to do messaging. So this is the cloud messaging that we talked about earlier. And also authorization, so that we can create a user and then link that user with their social media account. So these are the dependencies that I use for this project, and once again, they're all developed by first-party teams. So this is the entire project structure. It's only 13 files, and it's a little under 700 lines of code. I've personally written pull requests that were more than 700 lines of code. I've reviewed pull requests that were definitely more than 700 lines of code. So to have a fully functioning app that runs on both iOS and Android, and it achieves all the social networking capabilities of a modern day app, in my opinion, is goddamn amazing. So these are the 13 files that we have for the project, and in fact, 3 of these files, so 3 of these pages, are basically the same code with a minor difference. We're going to get into all these files next, but just to kind of drive this home, so 3 of these pages have the exact same code. They're just wired up to different Firebase paths, as we're about to see. So also, as Boris mentioned, main Dart is the main entry point for a Flutter application. And this is our entire main.dart file. It's not even 15 or maybe 20 lines of code, plus the imports. In Flutter, everything that you see on the screen is a widget, including the app at large. So the app is basically one big widget, and inside of it is a hierarchy of widgets that you can use, that you can add to your app to create your UI and to create your business logic. So at the very top, in our main.dart, every widget has a build method. So in the build method of this widget, we are returning a class called the OffProvider, which is a class that we create and we're going to visit in a little bit. But for now, I just need you to know that it's basically a widget that provides, it's a provider, an auth object to all the widgets that inherit from this OffProvider. And this allows us to know the state of the app, whether we're logged in or logged off. If we're logged in, we're going to be seeing content such as that on the right. So we can see our chat section, our friends section, our blog section. If we're logged out, we're going to be seeing the page on the left, which is the login screen. So this is essentially what the OffProvider widget does. It's what's called an inherited widget. We're going to go into it in a little bit. But for now, remember, it just gives us that off object, and we can use it to know whether we're logged in and show the content, or logged out and show the login screen. So this is our root page. And if we go back a slide to the OffProvider, we see here that we actually have to provide two parameters. So an auth object and a child. Our child is our material app, so this is our entire app is going to be living in this widget, in this one widget, and it's provided by the Flutter team. It's called a material app. It basically allows us to build an app with a material theme. So we provide a theme color, which is red, and we provide it with a root page for the home page, conveniently called the roots. So once again, this is our root page, and because this root page is encapsulated inside the OffProvider gives us an auth object, which we can, in the same build method that we discussed earlier, we can grab this object and we can detect the state, whether we're logged in or not. If we're logged in, then we should have data for the user. And if we have data for the user, then we should display the home page. Hence this question here, is logged in, then display the home page. If not logged out, then we're going to be displaying the login page. And because this is implemented at the root level of the application, this spans across the entire app. So if the token gets invalidated, or if the user clicks on the sign out button, then we're immediately taken to the login page. We don't have to worry about maintaining that state in any other part of the app. And the final thing in this page is that if the connection is not active, so we're kind of in between, we would instead be displaying a wait screen, which is just a loading spinner. In my experience, it was happening so fast I never saw it. So if we are logged in, then we are in the home page, which is the one that was on the right. And in the code, it's actually on the left, the home page right here. So let's check out the code of the home page. The home page encapsulates three different sections. A section for chat, a section for our friends list, and a section for our blog. These are the three main pages of the app, and I saved them in an array of pages. You can see them here, a chat page, a friends page, and a blog page. For this widget, for the build method of this widget, which once again every widget has, we are returning the same two things. So we provide a theme first, and we use the same color, so red, and the text is white, as you can see here, so the welcome text is in white, and the logout screen is in white as well. And so this is our theme data. And then for the home object, instead of providing, like previously we provided a root page, instead we're going to provide a scaffold. Scaffold is very much like a building scaffold, like a real-life scaffold. It's basically the hierarchy of your app. And you can use it to compose your app by just building a hierarchy that would reflect to the pages and the widgets inside of your app. So the scaffold in our case has three children, or three objects, I should say. It starts with the app bar, that's what we have here on top. And then composed right beneath the app bar, or before we go there, the app bar has two things. It just has a title and it has a button, which whenever clicked, it triggers the sign out method. So very simple, we use this to sign out in any part of our app. And then after the app bar, we have the body. And the body is basically one of the three pages inside the array dictated by the index called selected tab. So if we're in the chat page, this would be 0, and it would return the chat page, which is at index 0. And finally, we have the bottom navigation bar, which allows us to cycle between these pages. And whenever we click on any of these icons, what ends up happening is we basically we increase the selected tab counter, and it moves on to the next page. And so we end up with navigation across our app. And it has the icons and the text that you can see, so chat, friends, and blog. As I mentioned earlier, all three sections of the app actually share the same code. For simplicity, I abstracted out the connection to Firebase, and it all boils down to really just this scaffold that has three things. And you'll find this in the chat page, in the friends page, but also in the blog page. And as you can see, also visually, they're the same. So while functionally they're different and they represent different things, so the chat page obviously represents your chat messages and your chat conversations. The friends page represents your friend list. And the blog page is the public blog that you can post content to. But they all share the same code, and it's the exact same class for all of them. The difference is the Firebase path provided to all these screens. And as we're about to see, this path dictates which data to fetch from Firebase to display in our list. And we have one data set for chat, another data set for our friend list, and a third data set, which is a public data set for the blog posts shared by all the users of the app. So just to dive in quickly into the 3 items. So we have a post list, which is, for example, a message. It could also be a friend, and it can also be a blog post. We have a divider, which is a very thin line of 1 pixel height, or 1 device independent pixel, I should say. And finally, we have a composer. And this composer object is what creates the content depending on which screen we're on, which actually accepts the same path that's injected into the page, and hence post the content to that path. So if we're in the chat page, it's going to be adding chat messages. If we're in the friends page, it's going to be adding a friend. And if we are in the blog page, it's going to directly post to the blog. So this is the post list class, which is basically the list of either messages, friend lists, or blog posts. It's all the same code because they all use the post list class. And the post list class, it's called a Firestore animated list, which is a class provided by the Firestore team that allows you to map certain documents from your Firebase database directly to your display without having to write any of the boilerplate code, which again is very time saving. We can see here that the query, basically we fetch an instance of Firestore, which is another name for, well, it's a more upgraded version of Firebase, but same idea. And then we go to the collection path named path being passed into this object whenever we create it. So that's the query that tells us where to look for the data. The second thing that we provide is the direction of sorting. So the query is actually ordered by timestamp, and we're sorting it in reverse direction. So the more recent posts will be displayed at the bottom of the screen. And finally, the final thing that we provide is an item builder, which is basically a way to tell the Firestore animated list how to put together the list from the data we provided. So we know that our data comes, in the case of chat, comes from the chat data set. And in order to display it, we have a post item, which we're going to discuss next, which would be equivalent to either a text message or a picture message in this example. And we also have to provide it with a transition, an animation transition that tells it how to display items on screen and how to make them disappear from the screen whenever they're added or removed respectively. So this is the post item. This represents either a text message or represents a image message. Could also be a voice message in the case of the walkie-talkie app. And so it's once again, so all these classes are very simple, as you can see. I'm displaying the full code of every class as we go through it. In this class, we have in the build method, because it's a widget just like all the others, we have within it, we return a container that has only 1 row. And within that row, we have yes, we only have 1 row. So that row will either consist of the text, if the record from Firebase only has text. But if the record from Firebase has a photo URL, which is the check that we're doing right here, then instead it's going to use that photo URL to inject it into an image object, and then instead of showing the text associated with it, we would actually use the photo URL to display the text, to display the image. And then that text can be used, for example, as a hint to your image. So that was the post item. So that was an example of, for example, awesome blog post and this image of waterfall. Finally, there's the post composer. Even though it's the smallest component, it actually has the most code, but it's still not that much code. I would say this is about 35 lines of code. And what this does is, we can actually break it down super quickly. You can see on the far left, so this is this part of the screen right here. It's got 3 sections. One section allows us to pick an image to be sent as a message. And this will use the image picker, which is one of the dependencies that we talked about earlier. This allows us to natively pick an image from either Android or iOS directly and have it plugged directly into our code. And then after that, so once we pick an image using the camera or selecting it from the device, we calculate the timestamp, and then we upload it to Firebase storage using this line here. We get a reference to it, and we await until the upload is completed. Then once the upload is completed, we're going to have a download URL provided to us from Firebase, which we can then assign to be the full URL of a message, and then we use a method called sendMessage, and effectively this will grab the image, upload it, get a reference to it, and then send it as a message to our backend. The middle part is a text field. It's a simple field where we can enter any kind of text, and which is right here. It's the text field. And finally, this object, or this icon, this is the send button. Whenever we click on the send button, we will grab the text that's in the text field, and in the handle submitted method, I omitted here for simplicity, but in that method we basically call send message again, but this time instead of sending a full URL, we just specify the text of the message, and that becomes our message. And an example of that is awesome blog post on the top. This is our login screen. If at any moment our token is revoked, or if at any moment we never had a token to begin with, or the user clicks on sign out to invalidate the existing token, that would change the state of the auth object provided by the OffProvider, and then we would be immediately sent to the login screen. So at any moment, if we are no longer logged in, we're going to be greeted with this screen asking us to log back in order to view the content. Optionally, you might want to omit this if you want to have any kind of guest data that's available without logging in. But for this case, we're just going to use it the same way we use our most popular social networks. You have to be logged in order to see any of the content. This is the code for the login page. Once again, it's a widget, and it's got the build method. In the scaffold, we see an app bar at the top that's got some text. It says Flutter Connect, which is the name of the app. Then we have a container which has one column, and inside this column we have fields where we can enter data, and we can also have buttons that allow us to log in with an existing account, or create an account from scratch if it doesn't exist, or use some of the popular social media providers such as Facebook and Google, which I've chosen to implement for this project. So this is the build method, and these are kind of the utility methods that I use to build this class. There's 2 of them. One builds the input, so the email and password, and the other one builds the buttons that we need. And these are just UI methods that basically tell this screen what to do whenever we hit submit, and whenever, let's say for example, I click on login with Facebook, it would immediately trigger this login with Facebook method, which under the hood uses the same auth object that's provided to all the widgets that inherit from that root widget. So we can use that same object which tells us whether we're logged in or not, which is the auth object. We're going to talk about that next. We can also use the same object to send out API calls that allow us to log in or log out of our application. So it's a very convenient way to control our logged in state using that one object that's provided to all our screens. So this is our auth class. This is the magical object that makes us have a logged in, or makes us monitor the logged in state of the app throughout the lifecycle of the app. You can see here that it's got a callback called onAuth state changed. This is going to be triggered whenever the state, the logged in state of the Firebase user has been modified. So if we sign out, if I click on the sign out button, which is usually, it would be in the content part of the app, because that would be the signed in part. That's the only part we can sign out. So if I click on that, it will actually call this sign out method, and it's going to invalidate the token on the server and delete it locally from the device, all with one click without having to do any of that code ourselves. So that was the auth object, and it was provided to us by that first class that we talked about, the OffProvider. This is all the code there is for the OffProvider. It just has that auth object, which we instantiate in the first page of the app. And it overrides a method called upload should notify, which is a method that's part of the inherited widget. As we talked about earlier, the inherited widget is a class provided by Flutter that allows us to provide properties to all the widgets that inherit from that one widget. So for example, or in this example I should say, every widget in our app lives inside the OffProvider, and therefore every widget has access to this off object. And that's why we can control our state in a very seamless way without having to monitor it all the time. All right, so that's all the code for a full social network built using Flutter and Firebase. I'm going to switch to the emulator and simulator to give you guys a quick demo. So as you can see, we're already in the logged in state, and that's why we see the log out button, and also we see the content of the app. So we see the 3 sections that we talked about, the chat section, the friends section, and the blog section. I'm going to go ahead and log out on both devices. So this immediately invalidates tokens, and because the off object now has a state of logged out. So instead, we're being taken to the login screen, which was detected by whatever widget we were at or whatever screen we were at. The result is always the same. We're taken to the login screen. So this is our login screen. I'm just going to log in with Facebook on the Android emulator, and I'm going to log in with Google on the iOS emulator. So I'm going to use 2 different sign-in providers, but it's for the same user. And because I did this before, all my credentials are already saved on the device. So we can see that the Android emulator has already logged in using my Facebook account. It recognized my email, and it logged me into that account. There's a feature in Firebase that you can enable that would link up accounts that have the same email. So in my case, because I signed in with Facebook on one and I signed in with Google on the other, but I have the same email, so both accounts are actually linked. That's why it takes me to the same content. So now we're the same user logged in on both devices. Let's go ahead and give it a test to see if I send a message from one device, is it going to trickle down, go all the way up to Firebase, and then trickle down all the way down back to the iOS device? Let's find out. Bam. So as you can see, the message was sent on the Android emulator, made it all the way to the real-time database, and it was fetched and displayed on the iOS emulator. So this is kind of a mock of a chat example that we can have in our app. This is the chat component. If I switch screens now and I go to the friend list, so as you can see, my friends are friend 1 and friend 2. Can I add another friend? Let's name it friend 3. No, my friends have very basic names. It's not typing, all right. And as you can see, it has added a friend named friend 3. There's absolutely no validation here. I can add any friend, which is obviously not optimal. But this is just for demonstration purposes. So I was able to update my friend list with a new friend, and it was immediately reflected on the same account on my other device. And likewise, of course, the same behavior will be in the blog page, as once again, they're all sharing the same code. So functionally, they do different things, but the business logic behind it is basically exactly the same. So this is the blog post. Think of it as like a forum. So I'm going to do another test post. And bam, there we go. So these are the 3 sections of our app. These are the 3 main sections. We have the ability to interact with other users. We have the ability to push content. And we have the ability to automatically do all the caching and the saving and the API calls, all of that with very little code. I'm going to send it back out to the logout state. And I'm going to get back to the slides because I also want to cover a few more things that I have to do to get this project up and running. These are all the steps, the non-code steps that I had to do. It took me about 1 hour to go through all of them together. So each one of them was between 5 to 15 minutes, depending on how much I had to dig into the documentation. Usually not very deep, but I did have to go through and do all these steps. It's basically wiring up of Facebook, Google sign-in, configuring your Android and iOS projects to work with Flutter and Firebase correctly. They're all one-liner steps. but they all need to be done to get your project up and running. To give you a quick breakdown of everything that I did, so it took me about 1 hour to find the dependencies that I need. These are the 9 dependencies that we talked about in the beginning of the project. It took me about 1 hour, although it wasn't one shot, but 15 minutes here, 20 minutes there, added up to about 1 hour to write all the classes. And again, it's under 700 lines of code, so it's pretty basic stuff. And the extra steps in the end, the logistics behind it, wiring up the login providers, and getting Firebase and Flutter to work together on both Android and iOS. All that stuff took about another hour. So 3 hours was the total that I spent on building this project. And originally, when I wanted to prototype my ideas, I had given up after about 6 months. So clearly, 3 hours is a major improvement over 6 months. And if you have any ideas that you want to try out, you're absolutely welcome, of course, to use this starter code. It's very basic, and you can just use it as to fill in the social network component of your app. But there are some things that are left to do. So I'm just going to cover them really quickly to be fair in calling this a social network. So the first thing is, as we talked about, the friend list is not synchronized in any way. So I can send a message to anybody in the app as long as they're a user. In fact, even if they're not a user. If I put in a username that doesn't exist, what's going to happen is it's not going to link up to anything. It's just going to live on the database until that user does exist. For push notifications, right now the app is wired to receive cloud messaging, but all that happens is we just get a log message saying FCM message received with the payload of the message and the sender of the message. So we obviously, in a production environment, we want to wire push notifications to either launch the app or specifically take us to the part of the app that we need to go. So if you receive a new message, it should take you directly to the message screen. If you are subscribed to a blog post and there's a new blog post, the notification that you receive should take you to that blog post screen. And finally, there was no state management. Well, that's not true. There was a little state management in the code that we wrote. But obviously, if you want to take this to a production level, as Boris touched on the block pattern a little bit earlier, a block pattern is an excellent way to separate the business logic. So block stands for business logic component, simple enough. It separates the business logic from your view, and it allows you to decouple them and focus on each of them independently. So there you have it. That's how you build a social network with Flutter and Firebase in under 3 hours, and you're gonna look like that guy. If you're interested in the code, or if you have any questions, please feel free to reach out. My email is ahmed.youssef@shopify.com. That's my GitHub handle, and the code's going to be posted shortly. And thank you for listening to my presentation.